This is my second in my video on my module over proving trig identities. And in this video, we're going to lay out a formal set of kind of rules to go through when you're trying to prove that two trig expressions are actually the equivalent of each other. Okay, they're the same thing, but written different ways. So let's go ahead and visit these guidelines. We'll do a couple of examples, and then we'll move on to the next video involving a little bit more complex algebraic manipulation. So number one, okay, so let's start with this. Number one, it is usually, notice I say usually here, best to work on the more complicated side first. Recall that when you're proving trig identities, the point of it all is try to show that the, say, a complex expression can be rewritten as a simpler expression. So for example, in example number 3 here that we're going to get to in a minute, it is actually true, I'll just come out and say it, but the tangent times cosecant times cosine all of the same angle theta equals 1. So like it would be much more convenient to take this expression on the left here and just rewrite it as 1. But in terms of which side will we work with, well, you're going to work with the more complicated side, so we work with like the left-hand side. Number 2 is this. Look for trig substitutions involving the basic identities that may help simplify things. So in terms of like basic trig substitutions, these would be things like, hey, you know, cosecant is the same thing as 1 over sine, or that tangent is sine over cosine. Okay. As a matter of fact, we can start piecing this together here. We say numbers 1 and 2, looking at example number 3, we'd say, well, we're going to choose to work with the left-hand side, that'd be the LHS, and rewrite some things with basic trig substitutions. So we say tangent of theta, that'd be the same thing as the sine of the angle of theta, sine of theta over the cosine of theta, as opposed to writing tangent. Also, cosecant, as we mentioned, cosecant is the same thing as 1 over the sine of an angle, and this is all times cosine. I'm going to write cosine of theta. I'm going to put a 1 underneath just to see this a little bit more easily. So this is all just the left-hand side being rewritten this way. Okay. Number 3, it says look for algebraic operations such as adding, subtracting fractions. Okay, so you'd have to have a common denominator there. Using the distributive property, which we don't need until we get to example number 4 here, or factoring. Okay, sometimes factoring help us simplify a side that we're working with, or at least lead to an expression that'll be easier to simplify. Okay, a few things very quickly before we go back up to example number 3 and finish. But number 4, if there's ever a time you can't think of what to do, you know, everything can be rewritten as, you know, sines and cosines. So for example, tangents, sine over cosine. We could say that, I guess like secant, that's 1 over cosine. Basically, you could change it in terms of sines and cosines. And then last but not least, number 5 here says always keep an eye on the side that you're not working with, to be sure that you're working toward it. Okay, so like our goal here, like on example number 3 up here, for example, is to make the left side look like the number 1. So what could we do to get to, you know, this to be the number 1? Well, maybe I can get things to cancel out, because that was what would cause it to be 1. But essentially, you know, whichever side you're working with, just be clear that you're trying to turn it into the other side, essentially. So looking at example number 3, this expression we've been working with, you can see that you multiply fractions straight across. If we were to multiply this straight across, we'd have sine cosine on top, and we'd have cosine sine on bottom, but those would cancel out. But we can see here easily that this sine in here and this sine here cancel out. Those become 1s. And this cosine here and this cosine here, they cancel out, become 1s. Basically, you've got the product of 1s on top and bottom. So we showed that the left side can be rewritten as the numeral 1, which is the same as the right side. So first things first, we'll write check. This works. We were able to turn the left side into the right side. So what this means is the original expression on the left is equivalent to the expression on the right. We're able to rewrite that as an identity. So we'd write QED. That is what we wanted to show. Quod erit demonstrandum. So example number 4, let's put a few of these things back into practice here. But we say, look at the left side. We have cosecant times the quantity, cosine times the quantity, cosecant plus tangent. We also have cotangent plus sine on the right side. So in terms of like which side looks more complicated here, we're going to work with the more complicated side. It looks to me like the left side seems to be the more complicated side here. Okay, so in terms of the left side, I look up here at directive number 3, but basically look for any algebraic operations such as like, distribution, which we can't do here. Okay, you see that the cosine of x, if we took cosine of x times cosecant x plus tangent of x, choosing to work with the left side, we could rip this through using distribution and rewrite this entire expression then on the left as cosine times cosecant, cosine times cosecant, plus now cosine of x times tangent of x. Okay, so that's our distribution there. I don't see any factoring we could do. We're not adding or subtracting fractions. So now let's talk about some basic trig substitutions. So I would like to maybe switch out my cosecant and make it 1 over sine to see if that would be helpful here. So we say cosine of x times, instead of cosecant, is 1 over sine of x. We'll use our reciprocal identity substitution there. We say cosine of x here, cosine of x times tangent, which is sine over cosine. Okay, sine of x over cosine of x. Since I'm going to be multiplying fractions, it's not bad to go ahead and put these whole values over ones. But recall, you multiply fractions straight across. So a few things I want to mention here. First of all, if I multiply straight across over here, I just get cosine of x over sine of x. And possibly this helps, and maybe it doesn't help. I think it does help. We say plus. Now in this case over here, we see that since we're multiplying two fractions, we have a cosine on top and bottom. Those cancel out, and we're left with just sine of x. Okay, so let me get that red color out of there. We say sine of x. Okay, so now we've been working with the left-hand side, the LHS. Recall that I'm trying to get the left-hand side to turn into the right-hand side. And on the right-hand side, I have this. I have cotangent of x plus sine of x. Have we been making the left side turn into this? And you might be saying, well, hey, on the right side, I've got a plus sine x, and on the left side now, I've made this have a plus sine x. How could I get a cotangent out of a cosine over sine? But recall that with the simple trig substitution here, that cosine over sine is the same thing as the cotangent of x. We have sine x. So this is the left-hand side, and we were able to manipulate the left-hand side into being the right-hand side. So important things to remember are do any algebra that you can, factor, distribute, add, subtract fractions. But also do trig substitutions, and if you ever get stuck, just rewrite everything in terms of sines and cosines. So on to the next couple of examples.